Hi everyone, welcome to G World of Academic Physics. Already we have discussed some of the basic models based on Coulomb force. Today we'll discuss the model 8. What is the question say here? A ring having linear charge density lambda, having a charge q at the center of the ring, then find the tension on the ring. Look at the scenario. This is a ring having line charge density is lambda, and lambda, this line charge density can be defined as charge per unit length. And exactly at the center of the ring, a charge q has placed. The question is arised, find the tension on the ring. The first thing that will come in your mind, that can the tension be generated? Yes, tension can be generated because here the charges are positive and these charges are positive. Due to these positive charges, each charges repel each other. So what will happen? There will be a Coulombic repulsion. Due to this Coulombic repulsion, this ring can be expanded. So there will be definitely tension can be generated. So question is asking, find the tension on the ring. If this kind of question is asked to you, first consider a very small section. Look at, I am consider a very small section. It looking very large, but real sense it is a very small section. And it make a very small angle here. This angle I consider this is as d theta. As I consider a very small section, in this section the charge is dq, and this small section length I consider, this length as here to here length is dx I consider. I hope the scenario is clear to everyone. If you observe very carefully, here charges, it will be expand like this. So impact of tension will be like this. So due to repulsions, this tension is like this, this tension will be like this. I just want to redraw the same scenario, little broader sense. So this is the segment. The angle is d theta. Charge in this small element what I have considered, this is charge is dq. This element charge is dq. And this length, whatever I'll consider, this length is dx. And here the tension is like this, and here the tension is like this. Just making a small division here, can I say this angle is d theta by 2 and this angle is d theta by 2. Total is d theta and equally divided. This is d theta by 2, this is d theta by 2. This is tension, this is also tensions. I will break the two components of the tensions like this. Here I will also break the two component of the tensions like this. If this is d theta by 2, can I say this angle also d theta by 2? And this is 90 minus d theta by 2, and the same angle, this one is d theta by 2. One more time I want to repeat for the student perspective. If this is d theta by 2, this angle is d theta by 2, definitely this angle is d theta by 2, and this is 90 minus d theta by 2, so this angle is d theta by 2. Similarly, the symmetry perspective, I can say this angle also d theta by 2. If this is tension, so this is t cos d theta by 2, this is t sin d theta by 2. Similarly, I can say this is t sin d theta by 2 and this is t cos d theta by 2. I just break the components of the two vectors. So this is vector, the two components, this is vector, this is two components. If you look carefully, these two components equal in magnitude but acts in opposite directions. So this one and this one has cancelled each other. So the net is t sin theta by 2 and this is t sine d theta by 2. So this net, I can say the net is direction is like this. This is 2t sine d theta by 2. And if you observe these things, this is one center, one charge is here, and I already said this small element have charge dq, so Coulombic repulsion will be like this, and this Coulombic repulsion I can say k q dq upon, if I consider the radius of the ring as r, so k dq upon r square. So this one must be balanced of this one. So what is will come, 2t sine d theta by 2 equals to what I'll say, k q dq upon r square. The question I have given in term of lambda, and what I'll do here, 2 sine d theta by 2, this is k q, dq can be written as lambda dx upon r square, because lambda equals to charge upon length, so charge equals to lambda into length. These are the things we can say. So I just simply lambda and length is dx. 2t sine d theta by 2, this is k q lambda dx. If you think about the dx, this is my dx, this is my dx, and this distance is what? This is my dx, and this distance is what I have considered d theta, and this is your r. So what I will say, dx can be written as what? R d theta. So dx can be written as what? R d theta, because angle equals to arc upon radius. So angle d theta equals to arc is what? Dx upon r. So dx equals to r d theta. So I will substitute here r d theta upon what? R square. I hope the scenario is clear to everyone. Now going to the next step, this is 2t, this is sine d theta by 2, I can k q lambda, this is 1r cancelled, this is r d theta. Now look at the scenario. Here whatever the thing you are looking little zoom way, the broader sense, but this angle is very small. We are considering this is a very small angle. If theta is very small, d theta is very small, can I say sine theta is equivalent to theta? Yes. So here sine d theta by 2 is equivalent to, can I say, d theta by 2 only. So here sine d theta by 2 equivalent to, can I say, d theta by 2? Yes, I can substitute these things. So I am doing here, this is 2t sine d theta by 2, can I say as d theta by 2 equals to k q lambda d theta upon r. 1 2 cancel, and d theta cancel. What is the tension value is coming? K q lambda upon r. This is the desired result that we are looking for. What I have done here, one more time I want to repeat. I just consider this is the tension, this is the tension. I just break the two components of the tensions, and the Coulombic repulsive forces will be this directions. The net tension must be equals to this Coulombic repulsive forces. So this is the required result. I just arrangement, and here one thing I consider, if theta is very small, sine theta is equivalent to theta. So sine d theta by 2 is equals to d theta by 2. So 2t d theta by 2, I just arrange and will get the required result. If you observe this question also, what is the net force on this Q? What is the net force on this charge center Q? If you see, this is my ring, not a proper shape. It's a charge Q. each and every instant, if this section is repulsion like this section is like this, and this section, due to this section it will be like this, due to this section it will be like this. So what the thing we are observing, that the net force on this ring due to net force on this charge due to this circular ring is 0. So can I say net force on charge Q due to ring is answer is what? 0. Similarly, the net force on ring due to charge, net force on ring, similarly vice versa, I can say also 0. Why 0? Just have to be little visualize the things. This is my ring, this is charge Q, and each and every instant it will be radially outward. If this section it is radially outward, this section also it will be radially outward. In this section it will be radially outward, this section also it will be radially outward. So each and every instant the net force on this charged ring is 0 due to net force on this Q due to charged ring is 0, and the same thing also vice versa also true. That's why we are here, the net tensions, we are making this electrostatic force equalized and we are getting the desired result. I hope the scenario is clear to everyone. Thank you everyone. Thank you for your watching.